right, number 6. We want to solve for t. Right now, t is right here. T is being multiplied to 5r. I want to get the t all by itself, and what undoes multiplication? Division is what undoes multiplication. So I'm going to divide by 5r. Rules of algebra say if you do it to one side, you have to do the exact same thing to the other side. So the 5 is going to cancel. The r is going to cancel over there on the right. I would have p divided by 5r on the left, and the t all by itself on the right. So down here on this line on the bottom, t equals p divided by 5r. All right. In the center column, we want to solve this for k. Right now it's solved for g. G is the variable all by itself. I want to solve for k. K is up here inside parentheses in my numerator. So the first thing I need to do is get rid of the fact that this is a fraction. Fractions mean division. And the way we undo division is with multiplication. So I'm going to multiply both sides by what I see on the bottom, and what I see on the bottom is w. So I'm going to multiply by w. If you do it to one side, you've got to do it to the other. So my w's cancel. I'm going to have w times g on the left, 2k plus 1 on the right. I do not need the parentheses anymore here as I'm solving this because there's nothing else on that side anymore. So now I want to get k all alone. That means the next thing I want to do here is subtract 1 from both sides. 1 can't combine with the w or the g, so I'm just going to have wg minus 1 equals 2k. The 2 and the k are being multiplied, so I'm going to divide by 2. If I do it on the right, I've got to do it on the left. You can either do it as one big fraction, you can do it to everything all at once, or if you wanted to, sometimes it makes simplifying easier, you can do it to each term over there on the left. As long as you divide everything on the left-hand side by 2. You can't do it to some parts and not others. Right, my 2's are going to cancel here. So I have w times g minus 1 all divided by 2 equals k. Awesome. I've got k all alone. So k is equal to, I've got a fraction as my answer, w times g minus 1 all over 2. And there's my final answer. Last part of number 6. It is solved for t currently. I would like to solve for h. I want to get the h all alone. So here's h. I've definitely got to remember my order of operations here so that I make sure I do things in the right order. When we are solving for a variable, we go backwards through the order of operations whenever we're trying to isolate a variable or get it alone. I'm not going to move the h. I'm not going to touch the h. So it's this 2d that I need to get rid of. That's a plus 2d. So I'm going to subtract 2d from both sides to make it cancel out over on the right. There we go. That does not combine with my t. So I have t minus 2d on the left. And I have 3h on the right. And just like the previous problem, the 3 and the h are being multiplied together. So I'm going to use division to make that cancel. If you do it to one side, you've got to do it to the other side. So I'm going to divide everything over here on the left by 3. Again, you can distribute that to each piece. You could do t over 3 minus 2/3 d if you wanted to. These two things mean the same. All right, I've got my h all alone. I can write this either as one big fraction or as two fractions separated by subtraction. Man, I felt like I was getting confused in my words there. Since I wrote the other problem with just like one big gigantic fraction, I think I'm going to write this down the other way this time, just to mix it up a little bit. So h equals t divided by 3. That would actually be the same thing as 1/3 t. That 3 is really messy. 1/3 t minus 2/3 d. Or, again, you could leave that as t minus 2d all divided by 3. That would be perfectly fine.